So in this class we are discuss about the T flip-flop. That is one of the types of your flip-flops. That T flip-flop, it stands for your toggle flip-flop. This T flip-flop is basically is a modification to JK flip-flop. Yes, we have discussed that in this video. That is what is exactly T flip-flop. Next, there is a condition called as toggle condition. That's why it is called as a toggle flip-flop that we discussed in our video in truth table. That is our total two conditions. That first condition is no change condition and the second condition is toggle condition. So we will discuss in this video. So we start our discussion. So this is our logic circuit of JK flip-flop. Basically this is a logic circuit of JK flip-flop, and the modification is what you have to just connect that J to K. Here what if we connect this J to K, the line which is connected to J to K, so this flip-flop is now convert to T flip-flop, that is called as your now T flip-flop, having having a single input that is called as T input with one clock pulse. No issue, this is what a clock pulse, because we will know that this is what your synchronous sequential circuit. In this a clock pulse plays a very important role, and here clock always going to be 1, that is active high, that is clock is always going to be 1, and this is what your always high. Next, this is our basic that already you discussed, that is JK flip-flop, having this is what your NAND gate input with this latch circuit, and with this a feedback also system. Feedback system is connected to this. Next, though we discussed in our previous video. So this is our logic symbol of T flip-flop. This is a logic symbol of T flip-flop, having the single input, that is T input as input signal. We are saying that. Next, here the clock is one of the clock pulse we are applying, and here we get the output as a Q and Q bar. So this is our truth table. Truth table having with the two input, as already I told you, this is the combinations we are having with the two combinations, either 0 or 1. So as we can say that your clock pulse is, or the T, if suppose T is equals to 0 and T is equals to 1. So as T is equals to 1, with, as we will know that Qn, in our previous video also we have discussed that Qn is your present state, that is not your, because we can say that this is not your required output, that Qn plus 1, that is next state. That next state is equals to your present input plus your present state, that is equals to your Qn plus 1, and that is our required output. So that's why it is what your required output. So this is our don't care condition. So we don't know the value of this Qn, so that's why we have to just say that this is don't care. So here we have to just find out the Qn plus 1 for this 0 and Qn plus 1, that is the next state for this T is equals to 0 and 1. As basically already I told you, this is a toggle condition, and that's why it is called as a toggle flip-flop. As we people know that 1-1 condition, that in a SR flip-flop, that 1-1 condition where we called as a indeterminate condition. Next modification to that we are having with the D flip-flop, that if you are only that circuit want to set and reset, so we have to go with the D flip-flop, only just go for the set and reset, that output we got from D flip-flop. Next modification to that we are having with the JK flip-flop. That JK flip-flop is basically we are having with the 1-1 condition, that total 4 conditions, out of which that 0-0 is what your no change condition, 1-0-1 is what your reset condition, 1-0 is what your set condition, and 1-1 is what your we can say that toggle condition. Basically that 1-1 is what Qn bar, this that toggle condition, but there is a one again condition that is called as a racing condition, that we called as a race around condition. To overcome from this, we have discussed that here MSJK flip flop also, that is master slave JK flip flop. But here that T flip flop is basically related to your what, that JK flip flop, that is modification to JK flip flop, that we have to connect here that J and K input, and here we got the single input that is called as a T input. So here we discussed that Qn plus 1. So that case number 1 with respect to this T is equals to 0 means here if we can say that your T is equals to 0. If T is equals to 0, meaning of that T is equals to 0, so here the value of this is also 0, that input J, and here also the value is going to be 0. So with respect to this clock pulse 0 and 1, as 0 into anything that 0, so 1, so here the term with respect to this we are having it 1, and here also 1. So that Qn plus 1, as we are finding the value for this Qn plus 1, so Qn plus 1 is equals to, for this that Qn plus 1 is equals to 1 into Qn bar. So here 1 into Qn bar is equals to you 1 into Qn bar whole bar because of this complement. So here the term what, 1 into Qn bar whole bar, that is Qn. Yes. Next, if you want to find out the value of this, because this is unknown, no? So if you find out the value of this Qn plus 1 bar, so again for this Qn plus 1 bar, here we are having with 1 into Qn. So this is what your 1 into Qn whole bar, so is equals to your Qn bar. Yes. So this is what your Qn bar for T is equals to 0. So from this discussion we can say that this Qn plus 1 is equals to, means your next state is equals to your present state. Meaning this Qn plus 1 is what Qn, or your Qn plus 1 whole bar, that is what your Qn bar. So that's why this is what your present state and this is what your next state. So that next state is equals to your present state. So that's why this is what your Qn. We called as a no change condition. So that's why it is called as a no change condition. Okay. Next, second condition is what, that T is equals to 1. When T is equals to 1, here as T is equals to 1, so the J and K also going to be here 1, and this is also here 1. As clock pulse is always 1. As clock pulse is 1, because as clock pulse is 0, what happened? That that circuit is in a unchanged condition, that is no change, means we are getting the value here same, that is Qn. Yes, but here J and K is 1, now 1 1, and with this Qn bar, so here we are getting the Qn. Yes, Qn bar here what, by using this feedback system. So 1 into 1 with this Qn bar we are getting the Qn. Next here 1 into 1 with this Qn, so we are having with this Qn bar. Yes. So if we want to find out the value for this Qn plus 1, that with this condition, that is JK, I already told you that JK 1 condition, that is the last condition that already we are discussing in our JK flip flop video. So that 1 condition, that is last condition, we are getting the Qn plus 1. So here 1 is equals to, because we don't know the value of Qn is equals to whether it is 0 or 1, because they don't care, means that two condition, whether first is what, 0 or 1. So we have to check for these both, that is 0 and 1. So T is equals to 1, and we can say that Qn is equals to 0. Yes, T is equals to 1 and Qn is equals to 0, because we don't know the value for this. So T is equals to 1 and Qn is equals to 0. So what will happen, that Qn plus 1 is, because we are finding this value, this propagate. So here that for this NAND gate, that the NAND gate output we have to find out. So here that Qn plus 1 is equals to, what happened, that Qn plus 1 is equals to 0 into Qn bar, that because the value here we are having with that 0, so 0 into Qn bar whole bar. So as 0 into anything at 0 and is bar, so it is what your 1. So Qn plus 1 is equals to 1. If you are finding the value here that 0, that Qn is equals to 0, and we are getting here Qn plus 1 as 1. 0 we are putting for this t is equals to 1 and Qn is equals to 0, so we are getting the 1. So if you see here that 1 Qn is equals to 0, so we are getting 1. Next, so this is what your toggle condition, this is the changing. Now we are check for 1 also. So instead of this, if you go for the Qn plus 1 bar, we have to check for Qn plus 1 whole bar, that is equals to, we have to just find out for Tn, t is equals to 1 and Qn is equals to 0. So if we find out for this Qn plus 1 whole bar for this, so again for Qn is equals to 0, so what will happen as 0, that Qn into Qn bar whole bar is equals to, if the value is Qn is equals to 0, so 0 into that, or 0 into that particular anything at 0, so it's going to be 1. So as Qn plus 1 bar is equals to 0, so with this relation we can say that Qn plus 1 is equals to, that Qn is equals to is going to be 0. So here what will happen as t is equals to 1, as t is equals to 1, see as t is equals to 0, that change to Qn. When t is equals to 1, when Qn is equals to 0, we will get the value here Qn plus 1 is equals to 1, and when Qn is equals to 1, we can say that Qn is equals to 1, we will get the value Qn plus 1 is equals to 0. So that's why it is what toggle condition, that is what Qn bar. So that's why it is what your toggle condition. So from this discussion we can say that we are having with that t is equals to 0, that is Qn, and when t is equals to 1, we are having with the Qn bar. So this is what the equation for, or this is what the calculation for that particular truth table. Next, we can modify this truth table. We can modify this truth table also. That how we can modify this truth table, as we are having with this t, Qn and Qn plus 1. So if you again, there's t, Qn, that is present state, and our that is Qn plus 1 as next state. So what happened, as we are having with the 0, yes, and for this 0, as Qn is equals to, suppose we consider that Qn is equals to 0, yes, and that again 0 as Qn is equals to 1. Okay, so this is our first condition. Next condition, when Tn is equals to, or t is equals to 1, again that Q is equals to 0, and when this t is equals to 1 and this Qn is equals to 1, in this way. So here as 0 is 0, so here we are having with the same, that is Qn is what 0 and this is equals to 1, because that Qn is equals to Qn, or Qn plus 1 is equals to Qn. Next here, as we people know that Qn bar, here we are getting the Qn bar, meaning of that here if you apply the 1 and here what 0, we will get here what 1, yes, and next when we apply for clock here t is equals to 1 and Qn is equals to 1, we are getting here 0. So this is what the modification to this particular truth table. So if you modify here this truth table, and if you wanted to find out the value of this Qn plus 1, so we can find out this value by using K-map also we can find out. Sometimes this in a gate examination they ask the equation for this Qn plus 1 for T flip-flop or whatever the different types of flip-flop they also ask. So here the Qn plus 1 is equals to, by using K-map, by putting this value in a K-map, you will get the value your Qn plus 1, or simply by observing here, if we find out here that for Qn plus 1, where the logic if we apply, so here 1, where we logic 1 for this one, where T is equals to, or the T is going to be T bar and Qn. Yes, T bar and Qn plus, if we go for here 1, that Qn is again 1, so we can say that T and Qn bar. So this is the condition where we can say that A bar B plus AB bar, where directly we can say that by using this relation that A bar B plus AB bar, where this is a XOR condition, so we can say that this is what a T XOR Qn. So this is what your T XOR Qn, where the Qn plus 1 is equals to your T XOR Qn. So this is the final equation for your T flip-flop. So in this video, we have discussed about the logic circuit of T flip-flop, that logic symbol, next what the truth table, modification of this truth table, and by using this modification truth table, we have find out the value of this equation, that is what Qn plus 1 is equals to T XOR Qn. Thank you.